Hello, everyone. Thank you so much for joining us today. My name is Lucy Rack. I'm a cloud solutions architect focused in data and AI, and today I'll be covering fine-tuning. This call is being recorded and will be available on demand using the same registration link. Slides will also be available via Event Builder, and you can also ask questions using the Q&A feature, and we will leave some time at the end of the session for Q&A. So let's go ahead and get started. So when we think about fine-tuning, we oftentimes think about it within this hierarchy of language model customization. And you can see it's sort of an inverted pyramid or like a funnel, right? And this is structured like this because we really do envision this to be a journey where customer organizations should sort of start at the top here and work their way down as they prove that various areas are not meeting the needs that are required for the business case. And our hypothesis is that 90% of use cases will actually be satisfied by either adding your own data or prompt engineering. And the analogy, the metaphor I like to use here for large language models is kind of like building your house, right? So if I want to move into a house, I'm ready to make that jump, I have a couple different options available to me, right? I can build a ready-made house. That's just a regular house and I just move into it and it's ready for me now. That's kind of like adding your own data or prompt engineering. I have another option that's available to me in terms of building a fixer-upper, where I can do more of a renovation, do a gut rehaul, all that kind of stuff. And that's more along the lines of fine-tuning. Or I can custom build my own house, build it from the ground up, and that's sort of like training your own language model. So it's important to think about when you are considering fine-tuning or training your own language model, really making sure that you've pushed the boundary as much as possible with prompt engineering and with adding your own data. And in a little while, I'll go a little bit more into detail in terms of where are those situations where it really does make sense to consider fine-tuning. One of the important items to also keep in mind with fine-tuning is the economics and thinking about it from a costing perspective, right? So when we think about, just leveraging foundation model and prompt engineering, with the pay-as-you-go model, the token usage is really what's driving the cost, right? So the more you use the service and the longer your prompts are, therefore the higher your token usage is, the higher the costs are. With fine-tuning, there's 3 different costs that you're going to be considering, right? So firstly, there's going to be that upfront costs, the cost of the training time. Secondly, there's going to be the hosting cost for the model, since you will be responsible for that hosting cost of the fine-tuned model. And then thirdly, you're still going to also have the token usage cost, right? And we would expect it to be smaller in this case because fewer examples after fine-tuning would theoretically need to be included in the meta prompt as compared to when we're just leveraging prompt engineering. And if we kind of double click into this, it's also important to think about this from a usage perspective as well. So let's say we have a chatbot that we've built and we're leveraging just a foundational model with prompt engineering, or we're leveraging a fine-tuned model. In either case, our users are going to be asking questions of that chatbot intermittently, most likely. We might have some periods at maybe certain points in the day where we're not getting as much usage. And so if we're just leveraging the foundational model and prompt engineering, again, we're just going to be incurring those costs on an intermittent basis, right? But for fine-tuning, we are still going to be responsible for that hosting cost, which will be constant. And we are also going to still be responsible for the cost of this training time, right? And one thing to also just keep in mind here is that sometimes the training may take longer than initially anticipated, and maybe there might be a second iteration of training required, depending on the base model that you're using depending on the use case that you're looking to achieve. So I bring this up mostly just to also surface that there are some important cost considerations when looking at fine-tuning, and it's important to take that assessment and have a good understanding of that going into fine-tuning as well. So to take a step back here, what is fine-tuning really, right? So we have this concept from prompt engineering of this zero-shot, one-shot, and few-shot learning. And that's really how you're using those models to getting them to adapt and to be efficient on the asks that you have and on the use cases that you have, right? And when we think about fine-tuning, it's really that notion of you're transferring that learning, that notion of in-context learning that you have with few-shot and one-shot. And instead of doing that in the prompt, rather you're moving that workload up front, right, into the fine-tuning model of fine-tuning effort of training the model up front. However, it looks very different from few-shot learning from the perspective of the volume, right? Oftentimes, you're going to need to have thousands of examples that you're leveraging. The best practices will depend on the base model that you're using and on your use case as well, in terms of those training data points that you'll need. And you also need to have really high quality examples. The quality is super, super critical here, because just like in data science or machine learning, where we have that concept of garbage in, garbage out, the same thing is true. The quality is really of utmost importance. And when you're going through the process of fine-tuning, those training data do need to be in JSON format. You're following this notion of prompt and completion, problem statement and solution. And so we feed the model with these pairings, and then the output result of that is a fine-tuned model. And it's really a model that's been generated based on those training data with new weights and biases, right? And the value proposition of fine-tuning is that therefore the latency of your inferencing would be quicker. So you're also saving on that token usage, like we mentioned. But as we saw earlier, again, you do pay for the hosting of that model and for the training of that model. So it's always a balance. There's no one size fits all, and you do have to assess what the best approach is for each use case. So if we go into a little more detail here, ultimately it's really about having the model aware of that data domain language and the way that you're articulating language, right? Rather than having the model be aware of your data source or just of your knowledge source in general, right? Because we could achieve that with a semantic index. So when I talk about articulating the language and having the awareness of that, it's really thinking about maybe for a programming language, right? Making the model have that awareness of how to articulate within that specific programming language. And so when you're going through the fine-tuning process, on the back end, you're changing the vector space of that transformer model. And then this is what you're getting out of it, right? You're getting a fine-tuned model that's performing better with your domain-specific requests. And that's going to be in a new space from a vector space capability. So on the back end, this is what's happening to create that new fine-tuned model with updated weights and biases. So you may have seen this diagram before, this stream of data and where the Azure OpenAI service boundary is. I do want to call out some points quickly here that I think are important to be aware of. So the training data that you upload is stored in the Azure OpenAI resource in your Azure tenant. And the fine-tuned model belongs completely to you, is available exclusively to you for use. And when you think about that data that you have, that you uploaded as training data, that can be double encrypted at rest, and it can be deleted by you at any time. And all of that will be stored within the same region as the Azure OpenAI resource. Another important thing to call out is that training data uploaded for fine-tuning is not used to train, retrain, or improve any Microsoft or third-party base models. And again, we do have this notion of you are also able to apply to opt out of abuse monitoring and synchronous content filtering, and I'll be including the links and the relevant resources there as well, but important to call out these items. So what does that workflow actually look like that we're going through to get that fine-tuned model, right? So you start by preparing your training data, you select your base model, you go through that training process and prepare your training data to fit that JSON format, like we mentioned, and you fine-tune the model, deploy it, and then you use it, and you analyze the output of that, right? And so you can do that through the Studio web interface, the SDK, or the REST API. When you go through that process, you will have some options in terms of a few parameters that you'll be able to set. So I won't go into all of them in depth right now, but just at a high level, those are the number of epochs. So that refers to how many cycles the training has to go through, right? It can be a minimum 2, the batch size used for training. So what is the number of data that has to be, training data that has to be used, then the learning rate multiplier, it's the fine-tuning rate and the original learning rate, and then finally the prompt loss weight. So you'll have the option to set all of these as you're going through that process. When we think about best practices, again, the exact number of high-quality samples that you're going to want to have will depend on the model that you are looking to fine-tune, and again, on the use case that you're using. But again, each training example will need to consist of a single prompt and completion, so that input and associated output. For a classification task, for example, the prompt would be the problem statement, and the completion would be the target class that it should be classified into, right? For another example, for a text generation task, the prompt would be that instruction or question, and the completion should be that text ground truth, right? And again, as we've mentioned before, that ground truth needs to be really a very, very high quality. So we've spoken a little bit about best practices from the perspective of those training examples that you're going to want to prepare as part of the fine-tuning process, and also a little bit on the parameters that you'll be able to adjust as part of the fine-tuning process. But I want to show a very basic demo of how you can go through creating a fine-tuned model just within Azure AI Studio. So I'm here at oai.azure.com. And the first thing that you're going to want to be mindful of is which models are currently supported for fine-tuning and which regions are supported for fine-tuning. So today I'm just going to show a very basic example of fine-tuning GPT-3.5 Turbo, and I'm going to be using the region of Sweden Central. But always good to check back on this page as a source of truth to see what those supported models are and what those supported regions are. So if I go back into Azure AI Studio to start the process of creating my fine-tuned model, I'm first going to go into this Models tab, and then I'm going to select Create a Custom Model. So I'm going to choose the base model that I want to create a fine-tuned version of, and then I can add a suffix to label that and kind of use back for organization later. So when I have my training data prepared in a JSON file, I can either upload that from a local file, or I can bring it in from Azure Blob Storage or other shared locations. So in this case, I've already prepared a training set and a validation set, both in JSON files. And so I'm going to go ahead and just select each of those. For validation data, again, I'm going to go ahead and select the validation set that I had prepared, again, in alignment with those best practices of really high quality examples. From there, I'm going to be able to adjust my parameters as I need to. We discussed, kind of the impacts of each of these. In this case, just to keep it super simple, I'm just going to leave each of them at their default setting. And then from there, I'll be able to go ahead and select Start Training Job. So to keep an eye on the status of the training jobs, I can go into Custom Models, and we can see here, okay, this is running right now, right? And I have this one pending as well. In the interest of time, I'm going to go ahead and click into this fine-tune model where the training job has succeeded. And from here, I can see the training results, right? I have the log of the training events. And then I can also download the training files and the validation files that I used as well. From here, I'll be able to have the option to select deploy, right? In this case, I've already deployed this, so I'm going to go ahead and click Go to Deployment, right? So now I have my fine-tuned model deployed, all set to go. And where I can actually start to look at the behavior of this in a very basic way is actually within the chat playground, right? So I can go ahead and click into here, and then I can select my my fine-tuned model as the deployment that I'm using here. If I am interested in doing iterative fine-tuning, so I want to take a fine-tuned model and then add further, go through the fine-tuning process again, add further high-quality examples. I can also do that here, but in that case, I'll select Create a Custom Model, and for the base model, I'll use one that is already this fine-tuned model that I have deployed, right, instead of the other basic base models. So that's what the process of fine-tuning a model looks like in the Azure AI Studio. We also have documentation on how to do this from a code-first approach within our resources here. So also great to kind of take a look at what the approach is from a code-first perspective. But really, at the simplest level, if you want to, you can do it within Azure AI Studio. We've spoken about a lot of these items. One other one that I would like to call out is it can be of value to consider fine-tuning the smaller, less capable models, also just from a training time and from an upfront investment time as compared to the more capable models. And one other benefit of using those really high-quality samples is to help prevent hallucination and confabulation by the model. So when we think about when to use fine-tuning, really, as we mentioned before, it can be very valuable when the use case is very domain specific, right? And when the number of examples that we would otherwise need to include within a prompt engineering approach would be exceeding the token limit, right? It is important to have that high quality data, right? When we're really wanting to optimize for lower latency requests and be saving on inferencing costs, and for some cases where it really makes sense for us to look at fine-tuning a less capable model. I won't drain this slide here, but one consideration that we haven't discussed that I do want to call out is if you do have content that's rapidly changing, that might be a scenario where it would make more sense to index that with a semantic index rather than trying to fine-tune the model frequently. So here I've included some guides and examples for getting started with fine-tuning. You've also seen the demo in terms of just getting started within Azure AI Studio. One last item that I do want to call out is when we think about fine-tuning from an Azure perspective and looking ahead as well, some of the announcements that we've seen coming out at Ignite. So one of them is models as a service, right? I've linked out to the announcement on that, but where that will be coming into play is within Model Catalog, right? Which is the hub really for having a wide variety of these third-party open source models, as well as Microsoft developed foundation models they're pre-trained for various language, speech, and vision use cases. So within Machine Learning Studio, you can be evaluating and customizing and deploying these models with the native capabilities. And as you can see, you can filter these models for the various inference tasks and that you're looking to achieve. And also you can be filtering these pre-trained models based on what you would like to fine-tune it for, what specific set of tasks you would like to fine-tune it for, right? And we will also be doing a dedicated session on Model Catalog later in the AI Unlock series. So this is just kind of the teaser right now, and we'll be going into much more depth on it later in the series. So just to close on fine-tuning is really great if you do have the high quality data set and training, you want to improve your inferencing time, and you're facing issue with that, right? And you're facing limits in terms of what you're able to achieve with prompt engineering. But as we mentioned, it is important to think about what those upfront investments will look like for your use case and for the base model that you're targeting, and also thinking about it from a costing perspective as well. That concludes today's session on fine-tuning. Again, thank you so much for joining us today. Please look out for additional AI Unlock sessions in the coming weeks. Thank you.